Okay, hello everybody. I hope you can hear me. Looks like there might even be a live chat. I am going to be testing this based upon our first lecture from my class, where we make a very simple program to basically calculate the area and perimeter of a circle. One of the problems we have with physics, and it tends to be a big problem, is we don't do a good job coding. In fact, we tend to do a terrible job coding. Physics and scientific programs in general tend to be poorly formulated. They tend to be just a little rushed typically when they're written. And in this class, which is our second course in our computational physics program at Illinois Tech, we try to rectify that a little bit. So the first thing we're going to do is start a simple program, and we use Swift and Xcode in this, so we're going to create a new Xcode project. We're going to create an app for the Macintosh, and I am just going to call it Circle. And the important thing is we're going to include unit testing. Unit tests allow us to make sure that our code actually behaves as we want and that we don't accidentally break it somehow without our knowing about it. So I'm going to throw it in my typical folder, circle unit tests. And I'll set it up to create a small Git repository on our system as well. And now I have a little application. So in Swift, things are designed to operate with a GUI. That's fine. And we will, the GUI is controlled by the view controller. And so we'll just start with that. So the first thing we really want to do is just make a simple program. So we'll say let radius equal 1.0, for example. And then we could calculate the area. So let area equal, now fortunately pi is built in, so we have a double dot pi times radius squared. But the problem is the computer doesn't know radius squared, so we can't do that. So the way you actually square the radius is with the power function. So power radius 2.0. And then we can do print area. So Swift is a compiled language, so nothing will happen right now until I compile and run the program. And so to compile, I have to hit this little arrow which builds and runs the current program. So if I do that, should eventually have something come up. There we go. Window pops up because I get a window for free. Woohoo. And then I get a value printed 3.14159 down here in the little console box. That's great, but that's not terribly useful. To change the value of my radius, I have to recompile, stop the program, and run it again. Now I get a value 12.56. So this is the correct area, but my program is not terribly useful. And so this is not how we would leave a program like this. We do have, when we run the code, a window that pops up that could theoretically take input from the user and allow us to change some of these things. And so that's what we're going to do. So let's quit our program that was running, and let's give it some ability to interact with the program. To do that, we use the storyboard. Now I can put things into the storyboard. So for example, I can put in a little button. Now let's put the button in the middle. Change the name of the button, and we can make this calculate parameters. That's great. Now I have to tell my program that that exists. And so I have to connect up what's in the storyboard to the view controller. So to do that, I control clip, drag over, and I'm going to introduce an action. I can call this run calculation. Can also put in here text field. So something that might be of use would be to have a radius. So I can take the radius as an input, give it a label so I know what that is in the GUI. And then I might actually want to be able to display the area and the perimeter. So it's not that hard to make a simple GUI. Pretty straightforward. And then I also have to let my view controller know that these exist as well. So I control click and drag over. So I'm going to call this the radius box, because that will hold my radius value. Area box. And perimeter box. All right. I can close this to give myself some more room. So if I want this program to just do the exact same thing, I can copy and move this code. I'm just going to cut it. And put it down here in this action that gets called whenever I press the button. So I can build this code quickly. Hit the calculate parameters button, and just like we had before here, we had a value printed for the area of the circle. Not bad. Pretty quick, pretty straightforward. But we still have to stop the code and recompile it in order to change the radius. Now if I say the radius is equal to the radius box dot double value, I can pull a value from within the radius box. So I can type text into the radius box and change the value every time. And printing it to the console window isn't too terribly useful. So I can also display that to the window. And I do this roughly the same way, just in reverse. And I can say that area box dot double value is equal to the area. Now if I compile and run this code, I can change the value of area or in the radius box, make that 1, hit calculate parameters, and now the area actually displays in the area. And I can change this to 371, and I get a value that shows up every time. Now, I'm roughly done. I could put in easily the same thing for perimeter. I can type let perimeter equal pi again, double dot pi times 2.0 times the radius. And then I can go perimeter box dot double value equals perimeter. Recompile the code. Oh. And I get an error because I didn't type it in right. There we go. Type in 1.0 for radius, calculate, my area is pi, and my perimeter is 2 times pi. This is great. So I'm done. I have my code that calculates pi, displays it to the user, takes interaction from the user. But this isn't good scientific programming. Why not? Well, because it's not very reusable, for one. I can't easily share this code with other people. This is a fairly simple example, but it's not well documented at all, and it doesn't allow me to test for anything to see if I have the right value. If I accidentally come in and make a typo here and accidentally change the perimeter from 2 to 2.01 and rebuild it, and type in something that I don't really know the answer, 371. Now my perimeter is incorrect, but I don't know that it's incorrect, and that's a major mistake. So how do we go and rectify these things? And why is this something that we really should do? Well, the important thing is, if you're a grad student or an undergrad and your job is to write code for people, the last thing that you really ever want to do is be stuck. Oh, thanks, somebody responded. It's good to hear this is actually working. All right, the last thing you really want to do is be stuck having to support code for the rest of your life. And that has happened to most of us who have written some scientific code, especially when we didn't do it well in the first place. So you still get to hear back from people. Now, the funny thing about scientific code is it does tend to be used forever. The Herman Skillman code for making wave functions was put together a very long time ago. And I still use it modern day, physics codes tend to last forever, and you will end up supporting them if you're not careful. And not careful means not writing it correctly. All right, so let's fix this. Let's make this better. It works. Oh, it doesn't work right now because it's still broken. Let me fix that. All right. Change that value back. So how can we make this better? Well, one of the things that we can do is we can abstract some of this work into functions and classes. So a circle, if I start thinking about it, is a very high symmetry system. And it's related to something else. It's related to an ellipse. So a circle is actually a subset of an ellipse. So if I want to make this more general and more generalized, maybe one of the things that I could do is make this work for ellipses and circles as well. And so let me create a class. So I can create a new file and make a Cocoa class here. And I am going to call this Ellipse. Ask me if I want to create the file. I will create the file, and it shows up here. So I'm going to import Cocoa. I'm going to import Foundation, so I have a few other things as well available to me. Now I have a new class called Ellipse, and it's an object. So this gets us back in the mode of object-oriented programming. So I can create a number of objects of type ellipse. Now my ellipse should have some parameters associated with it. So we can type these into the class as variables. So one thing that characterizes an ellipse is the semi-major axis. And we'll say, initially we'll just populate that with 0. And it has a minor axis, so we'll have a semi-minor axis length equal to 0.0. An ellipse has a center. Now the thing about this, and so the center will have x coordinates 0.0, y coordinates 0.0, is as you're coding and as you're typing these things in, you don't have to get them all correct the first time. You may leave something out. You may decide, oh, I need to add that later. And so let's go ahead and start adding things. Oh, you know what? We're probably going to need an area. Probably going to need a perimeter. All right. So let's see if we need anything else. All right. So we're going to need some methods within our class or functions. So we can create a function. And our function will be, no, let's init with axes. And we'll call it the semi-major axis. And let's make that a double variable and a semi-minor axis. Semi-minor. I'll make that a double variable as well. And yeah, I can't spell in real life either. All right, and we're going to tell this function to return a Boolean so it lets me know if I successfully created the function. So if the function gets created, I'll return true, and I can use that for testing. And so what do I need to have in this function? Well, I could say my semi-major axis length is equal to the passed-in value, semi-major axis. Autocomplete's a great thing, especially when you're trying to use good variable names. So if you notice here that I am not using variables like A, B, C, and D, because it makes the code easier to understand for other people. And that is very important. You want people to understand what is going on and why it is going on. So then we have our semi-minor axis length is equal to the semi-minor axis. Next step, and the code is this integrated developer environment. Xcode is very useful, although it nags at you a lot. It's telling me I'm missing the return function that's expected to return a Boolean. And so if I want to fix that, I can just say return true. And then that error or warning will go away. That was an error and not a warning. So there you go. Now I actually match up with the requirements of the function. So the next thing I want to do is to calculate. Oh, video is blurry from somebody. Oh, that's not great. It could be a bandwidth issue on my end as well. I don't know how great the bandwidth is, but yeah, that could be a downside. But I've got some people say looks good, clear audio. Some people having some bandwidth troubles. This is all good to know. I appreciate everybody's input on this. All right, so calculate the area. Now, I don't know what I need to calculate the area, but I know it's probably going to involve the major axis. And so I'll pass in the semi-major axis length. And then I'm probably going to need a minor axis as well, minor axis. And pass in the semi-minor axis length. Okay. Probably going to need to calculate a perimeter as well. So calculate perimeter. And again, that's probably going to need a major and minor axis, so I'm just going to steal it from right above. All right. Perfect. Okay. Now, if I look, I get two errors. Use of unresolved identifier calculate area. Use of unresolved identifier calculate perimeter. And that's because it has no idea what these functions are. So we need to make some new functions. So we'll have functions calculate perimeter, calculate perimeter. And I know it's going to take a major axis. And that'll be a double. And a minor axis. And that will also be a double. No idea what goes in there yet. We'll need another function. Calculate area. Major axis. Another quote. Probably good. Set computer to funky low resolution so the code. Yeah, okay. We'll try that next time. Okay. funky low resolution. Yeah, that's probably a good plan to blow this up, because one thing I've never ever figured out how to do in Xcode is how to actually make the code actually show up bigger for those of us with terrible eyes. So major axis double, minor axis double, and I don't know what goes in there yet either. All right. So, awesome. Let's do the area first, because that's probably easier. Famous last words. So let's put in a little bit of a comment here. The area is equal to pi times the major axis times the minor axis. Cool. So I have a variable area up here that belongs to the class ellipse. So I can say area is equal to double dot pi times the major axis times the minor axis. It's not great readability, so let's throw some white space in there to make it a little easier. Perfect. And I can return when I'm done with this function. All right, so that should actually calculate the area of an ellipse. Perimeter is still a little difficult. So the perimeter of an ellipse doesn't have a well-defined function, but it's approximately equal to pi times a plus b times 1 plus 1 over 4h squared plus 1 over 64 h to the fourth plus 1 over 256 h to the sixth plus a bunch of higher order terms where h is equal to the major axis minus the minor axis, all divided by the major axis plus the minor axis. All right. So I need to calculate h first, so I can go let h, and this is not going to have changed, so it doesn't need to be a variable, it can be a constant. So let it h be equal to the major axis minus the minor axis divided by the major axis plus the minor axis. Okay, so I have a variable perimeter. Perimeter is equal to double dot pi times major axis plus the minor axis, now times a bunch of other parameters. So that will be 1.0, because I want it to be a double value and not an integer, plus 1.0 divided by 4.0. And if you're worried, it never hurts to throw in parentheses. Parentheses are a good thing. So 1.0 divided by 4.0 times power h comma 2.0, and that will give me my h squared plus 1.0 over 64.0 times power h to the fourth plus 1.0 divided by 256.0 times power h to the sixth. All right, and so that gives me my perimeter function. I can return from that function. All right, so theoretically now I have a working ellipse class that should be able to take the values, store the values from the ellipse, and calculate its perimeter and its area. Okay, that's not bad. But there's a little bit of a problem here. And the big problem that we have here is that the perimeter of an ellipse is not exact. It's approximated. And so when we want to calculate the perimeter of a circle has a well-defined perimeter, and that's pi d or 2 pi r. So we don't want to have an approximated value when we could use an exact value. So we're going to create another class circle that's a subclass of an ellipse. Did I spell ellipse right? Yeah, at least I spelled it the same way. No, I didn't. There we go. All right. Now I have a circle class that's a subclass of ellipse, so it contains all the same parameters and functions that exist in the ellipse. Now, a circle has a radius that's the same as the major axis and minor axis of the ellipse, so we'll give it a value radius. Now, in the ellipse, we had init with axis. In the circle, we'll want to have a function that is init with radius. And instead of having a semi-minor axis and a semi-major axis, we'll have a radius value. Just call it past radius, and this will be a double. And just as we had before, we'll have it return a Boolean so we know that it worked. Okay. So we'll have radius is equal to the passed in radius from the function call. And we'll do calculate area. And now here, the radius just gets passed as both the as the major axis and the minor axis. So we don't have to rewrite that. We can calculate the perimeter. Again, passing radius to both as the major and minor axis. And we can return true if it's actually created. All right. Now, like I just said, though, we have a little bit of a problem. And so we are now using the perimeter function from the ellipse that isn't correct. And so we want to change that. We want to override that when we're using it in the circle. So we're going to override calculates perimeter. And instead of using the approximation, we're going to say the perimeter is equal to 2 pi times the radius. So we'll say perimeter is equal to double dot pi times major axis plus minor axis in this case. Now, we'll pass the same value for radius into both, so this will be radius plus radius, or 2 times the radius times pi, and that gives us our correct value for the perimeter, and it is now an exact value. Okay, so how do we utilize our classes now that we've created them? Well, we can go back into our view controller and look at our run calculation function. And we can change these. So I'm going to create an instance of my object. So I'm going to say let my circle equal circle. I'm going to have a variable was created. Equal to false. And then we have to get the radius again, because we still need the radius. Now I've already replaced these 2 lines with values that were in our class, so I can just delete these. Now I get a couple of warnings telling me that things aren't used, and now I've got errors because I deleted area. And now to calculate the values, I can do was created, which is my Boolean, is equal to my circle dot init with radius, and I'm going to send it our value radius that we get from the double box. This now contains a value for the radius, the major axis, the minor axis, and the perimeter and area. And now I can access these at any time, but only if was created is true. So I can check if was created. Then I can take these 2 things, paste them up in here, delete them from here. And now I don't have area anymore, but I have my circle dot area, because that is stored in my circle. And I have my circle dot perimeter. And it's telling me that I don't have a was create. That's because I misspelled it. So if I make that was created, perfect. Now, what happens if I run this? So if I put a value in for the radius and hit calculate parameters, I have an area, I have a perimeter. And I can change these values up, see what happens, works great. So now I have something that works. And it's something that's reusable, because if I ever need to calculate an ellipse parameter or a circle parameter in another program, I can just copy these files, ellipse.swift and circle.swift, directly over. And they are reusable. I have a little bit of comments in here, not great comments. And that's something that I will fix next. So I can come in here to my ellipse, can click somewhere on the function, and then I can go editor, structure, I never remember where it is, selection, font size, theme, product. I hate when that happens. There we go. Add documentation. So it's editor, structure, so editor, I just had it. Yeah, editor, structure, add documentation, and it allows me to describe my function here. So I'm going to tell it my description, in this case, is init with axis. And init with axis basically populates the axes and the minor axis, and then runs the calculation. Perimeter and area. All right, so we have the semi-major axis variable has to be past the semi-major axis of the ellipse. And the semi-minor axis has to be past the semi-minor axis of the ellipse. I wanted to be careful, I can say this has to have units of length, and this also has to have units of length. You can do the same thing down here for the perimeter. So editor, structure, comment selection. And you can see I am old school. There is a keyboard shortcut for this. Add documentation is what I want to do. But I am ancient and don't remember keyboard commands, and so I tend to always go up to the menu items and grab stuff. All right, this function, calculate perimeter. Actually does the calculation of the perimeter, and it uses an approximation. So the major axis, same thing. It's the semi-major axis of the ellipse. Copy that from up there. Semi-minor axis. Drop that down in there. Again, both of these have units of length. calculate perimeter, and I can do the same thing for calculate area. Calculate area does the calculation of the area, and this is exact. It has the same major and minor axis, so I'll just copy and paste. Now, just by quickly looking at this, we have an idea. It's well documented. If 3 grad students from now has to go ahead and use this, they will be able to use this. They'll be able to understand what's going on because the approximation is listed in terms of the perimeter. Should go and do the same thing for the circle as well. So I can go into the circle. Knit with radius, editor, structure, add documentation. So this basically initializes with radius, initializes the circle with the radius, and calculates area and perimeter. Okay. This is the radius of a circle, and the units again are length. Okay. And now we can also do this down here, editor, structure, add documentation. This is calculate perimeter, and this exact in case of a circle. And it has to be past the radius twice. So radius, radius, units of length, units of length. All right. So now I have this fairly well documented and everything's written down. People should be able to look at this. Come back into my view controller again, see everything there looks very good. I can stop it, build it. Adding the comments shouldn't change anything. It should still work. And I get my value of area and perimeter. However, the one thing I don't have is any protection in case I come back and modify the code and change something so that it's incorrect. So in case I look at this and go, oh, I should have had a factor of 2.0 in there. This would not be correct, but I could easily compile this, run it, and my area will be correct, but my perimeter is going to be off. And there's no way I would know that if I did not check this against some known value. And that's what the unit testing is for. So let me close the program. Let me get rid of this value here. Let me just save that. I don't have to run it to save it. But we have these unit tests. And the unit tests allow us basically to verify that we haven't broken the code. And so we can put in a test for known values and examine them to make sure. So this file gets created. You have to import the test parameters, xctest, and we have to tell it what's testable, and that's our circle program. There's a lot of things that you can do, set up, tear down. We don't really have to do anything serious for that here. But what we do have to do is tell it what to test. So here's an example. Let's give it some white space in there. And we'll rename this because test example isn't that useful. So let's give it a test of the circle area. So this is going to be an example of a test case of the area of a circle. Okay. Now to do this, we have to create a circle object, just as we did before. So we have to instantiate our class, and it would probably help if I spelled it correct. That actually is spelled correct. Amazing. All right. So we have our class. We're going to give it a value for the radius equals 1.0 here. And then this is going to return a Boolean, so we have to give it something to store it. But if I gave it a variable that we weren't going to use, it would yell at me because that's insecure. So using an underscore here tells us just throw away the Boolean because we don't really need it. And so then we're going to go myCircle.init with radius, and we'll pass it the value of radius 1. Now, the testing requires us to check this value. So do we know what the value of the area should be? So to test that, we have an XCT assert. And we're going to assert that it's equal. And so we're going to have this be checking to see if myCircle.area is equal to the known value, that in this case is double.pi. And because these are doubles, you can't use an exact equal. They will almost never be perfectly exact, because there's always round off error in the variables. And so we have to say it's equal within some accuracy value. And we can do, say, 1e minus 7. Okay. And we can then tell it to give us some sort of a notification or string. This was incorrect if it's not correct. Okay, cool. Now, what happens? How do I use these tests? Well, I select product and test. And if things are correct, I get little green check boxes. So I was able to run my functions, create the value of a circle, plug in the value of radius was 1, and within our level of accuracy it was equal to pi, and so it passed that test. So let's give it another test. Test circle perimeter. So here we can say this is a test of the perimeter of a circle. And we have to do the same thing. So we have to give it a value, a known radius, and instantiate our class. So let my circle equal circle. Let radius equal to 1.0. And call the same function again. My circle dot init with radius with our past value of the radius. And then we need another assert. Equal. And so here we have my circle dot perimeter. And this should be 2.0 times double dot pi. We can use the same accuracy. -7, and if it's incorrect, we'll let everybody know that it's incorrect. Now, if I went back into our circle and accidentally broke it with this value of 2.0, came back and did our test. Now it says our test failed. Our test failed because we're off in pi. So instead of getting 2 pi, we got 4 pi back. And so that's where it actually failed. And we can see that. Test circle parameter failed. And it's because 12.56 is not equal to 6.283 within 1e minus 7. So that tells me, oops, I must have screwed something up. So if I go back and look at my code, I can see exactly where I screwed it up. I put an extra factor of 2 in because I had confused by major axis and minor axis. So I can delete that, save it, and rerun the test. And now the test succeeds. Everything passed. I have a nice green checkbox there. So all I've done so far is test the circle. May as well write tests for the ellipse. So function test ellipse area. This is a test of the area of an ellipse. And so now I have to have my ellipse class instantiated, so let my ellipse equals ellipse. Let major axis equal 3.0. Let minor axis equal 2.0. Is equal to my ellipse. Yeah, I got the clock ringing in the background. Not great. Dot init with axis, major axis, and minor axis. And so now I have my assert. And so we have here my ellipse dot area, and the value here in this case should be 6.0 times double dot pi. And my accuracy, go 1 e minus 7. And if it's wrong, this was incorrect. You could come up with better sayings if you would like there, but that seems to work for me. And we have function test ellipse perimeter. And use the same. Tested the perimeter of an ellipse, and my ellipse and it with axis. Then we have our assert equal, and this one will be my ellipse dot perimeter. In this case, our value should be 15.865439.86543952671. Accuracy 1 e minus 7. This was incorrect. And I can test these just as well. So my test succeeded because I know what all these values should be. Everything is correct. Now, a lot of people, when they're building code, argue that you should do this the opposite way. Here we built the code and then wrote our unit tests after the fact. So we put our unit tests together afterwards. We could have done the opposite. We could have written our unit tests and then written the code to make sure the unit tests were passed. That is almost certainly a better programming practice. However, when I'm doing scientific programming, it's usually just a touch rushed. I don't necessarily always know exactly what I'm trying to do or how I'm going to go about doing it. And I often don't know what answer I should get in advance. And so in many of those cases, writing unit tests is a little hard to do first. So I usually write the code. I try and document as much of it as I can as I go along, and then I try to comment it nicely. I always try and use good variable names, but these are the practices that we think you should get into the habit of. There's one last thing that you should do, and that is use version control. So if you look, I've got these blue lines that have popped up on the side, and it's telling me because that these are where I have made changes. I have made changes in the code and I haven't committed this. So if I go source control, I can actually commit this to the repository. This will be my first commit. And this way, if I screw something up later, I'm going to commit 6 files, I can always revert to that previous version of the code, and I don't lose things that way. So this was a very simple program. We'll do much harder programs over the course of the year, but this is the kind of process that you should go through as you start coding in our class here. All right, hope this helps you, and thanks everybody for watching. Appreciate your help.